In this video, we are going to still work in Part Workbench, and we are still going to create some primitive solids or primitives, but in a different way. The icon just next to create torus that we did last time is creation of parameterized geometric primitives. When you click on that button, geometric primitive panel opens up. There is a drop-down menu here. When you click on it, you'll be able to see that not just the box, cylinder, cone, sphere, and torus, but there are all other different types of geometric primitives that you can create. So, which are the new ones? You can create a plane, you can create an ellipsoid, you can create a prism, a wedge, a helix, which is very helpful in creating your springs. You can create spiral, circle, ellipse, point, line, and regular polygon. So let's start from the top. Let's create a plane. You just need to enter the length and the width of this plane. Let's just make it 100 millimeters long and 150 millimeters wide. When you click on create, that plane will be created. Now this technically looks just like the creating of a cube, but you will know the difference that there is no height parameter here. So as you can see, it's just a two-dimensional plane. Now there are many uses of this two-dimensional plane, so this becomes very helpful. Now the other thing is, if you click on the bottom panel of location, you can actually make this plane or generate a plane in different locations. So just instead of having the direction in Z, so the normal of this plane is in Z direction. Instead of that, if I just want it in X direction and I click on create, you can see that this entire plane now is generated with the same length and width, but now the direction is X direction. Similarly, you can create a plane at different locations. So let's create a third plane at X equals to 100. When I click on create, you can see that a plane is created at a distance of 100 millimeters in X direction. The normal to the plane is in X direction, and the length and width are 100 and 150 respectively. Next, we are going to create an ellipsoid. When you click on an ellipsoid, or when you say you want to create an ellipsoid, the parameters for ellipsoid are radius 1, 2, and 3. There is a U parameter, a V parameter, and again the same thing, positions X, Y, Z, and direction in X. So let's reset the location. So let's make it 0, 0, 0, and let's make the direction Z as it was originally. And just with the default radiuses and everything, let's just create an ellipsoid. So when I zoom in, you can see that an ellipsoid has been created. Now if I close this, if I come back to this ellipsoid, I can now change radius 1, 2, and 3. So instead of 2, let's just make it a 4 millimeter radius 1, and then let's recompute, and you can see that now radius 1, 2, and 3 all are 4 millimeters. So this virtually is a sphere. So there are other ways of creating this sphere. Let's bring it back to 2 millimeters. Recompute. Now if you change radius 2, let's make this 10 millimeters and recompute. You can see this ellipsoid is stretched. So if you just look at the top view, it will look like an ellipsis. And then let's change radius 3. So instead of 4, let's just make it say 20. When you do that, the major axis of the ellipse now changes from what it was in x direction. Now y direction is the major axis. So that's how you can change the three radiuses, and the shape of the ellipsoid will change. Now again, angle 1, 2 and 3 would be same as what you have for a sphere. So if I made this angle 1, 0, you can see that the bottom half of the ellipsoid is chopped off. If I made this minus 90 and made this 0, you will be able to see that the top half of this ellipsoid is made, or it's chopped off. Let's change it back to 90, and then if I make this 45, then only 45-degree ellipsoid will be left. Let's change it back to 360 degrees. Now this didn't recompute, so let's click on it and recompute. Next, let's go back and create a prism. So as you all know, the prism is any of 3, 4, 5. So any polygon with 3, 4, 5, 6, 7, 8, 9, n number of vertex, and then it has a radius. So if that polygon is extruded out, that's how you get a prism. So for ease of clarity, let's just make a polygon with 3 sides. So that's a triangle. The circumradius of this, let's make it 200, and the height will just make it 100 millimeters. When I click on create, you will see that we get a prism, and that prism is extruded out by 100 millimeters. Now if we create a circumradius, then the radius of that circle would be 200 millimeters. Now to change this, I can go in and change here. So if I make it 5, we get a pentagonal prism. Now I can change the circumradius here, make it 100, and the size of that will change. How about let's change the direction of it, or the location of it, and let's also move the ellipsoid here. Now with this prism, there are only 3 parameters that you can change: the polygon, the circumradius, and the height of this polygon. Next, we are going to see how to create a wedge. So for the wedge, there are a lot more parameters that you need to enter. Now, for the sake of it, let's just create the default wedge, and we'll see how it looks like. Let's close this, move this wedge out. So that is how you create a wedge. Next, we are going to see how we can create a helix. Now for the helix, the parameters are pitch, height, radius, angle, and coordinate system. Now if you want to just create the default helix, just click on create, and a default helix would be created. Now if I zoom in, I can see that the helix has been created. If I want to make it a bit bigger, let's make the pitch 10 and the height of the helix as 100 and the radius as 5. Now when we do that, you can see that the helix length, as in the height, has changed. And also, first of all, let's just move this towards right, and then we can go in and have a look. Now each and every section of this helix has been divided into 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 parts. Now why is it 10 parts? Because the pitch is 10 and the height is 100 millimeters. So 100 divided by 10, you get your each and individual components. Now say for example, if the pitch was 25, you can see that you can 1, 2, 3 and 4 individual slices of this one. Now instead of that, let's make the radius as 2. Then you can see that when you look it up from the top, the radius is 2, so you get a very smaller radius of a spring if you think of it that way. And if I make this 25, then you can see that this is a larger spring. Now where is this helix used? If you create a circle at this point, a face, circle with a face, and then you extrude this circle over this helix path, you will get a spring. Next, you have a spiral. Now again, for default purposes, let's just create this spiral as it is, and let's go in and evaluate this one. But first, let's just change the location of this spiral. Now with this spiral, the growth is 1, radius is 1 millimeters, and rotation is 2 millimeters. So let's just first make that growth as 2 millimeters. So you can see that the entire spiral grows by double the radius, or double the size of what it was originally. If I change the radius to 2, you can see, let's make it 20. So you can see that the radius of this spiral has changed, but the growth has still remained the same of 2. And the rotation of 2 millimeter, the number of rotations. So let's make it 5. You can see that the number of rotations, so from this point to this is 1, 2, 3, 4, and 5. So as you can see, there are 5 rotations of this spiral. Now again, if I change this to 1 only, you will be able to see that it's just one spiral. Now if I change the growth to 15, you can see that the distance between these 2 points is now 15 millimeters. Okay, and the radius is just the inside radius of this spiral. So that's how you create a spiral. Next on the list, we have a circle. Now circle is very easy, it's just the radius. How big is that circle? Angle 1 and angle 2. So if you want to create an arc, you can create an arc from this circle. So if you want to create a 90-degree arc, angle 1 is 0, and angle 2, if you make it 90, you get a 90-degree arc. You can also create this circle from 3 points, but as we don't have any 3 points right now, it'll be hard for us to create this this circle unless we select 1, 2, and 3. So any random arbitrary 3 points if we can get, then we can make a circle from 3 points. Let's make this radius as 20 millimeters and create a circle. As you can see, circle has been created. I'll move it out. Now this circle has same properties: radius, angle 0, angle 1. Now if I change this to 90 degrees, this circle now becomes an arc. So now if I want to make it a circle, full circle, I'll make it 360 degrees and you get a full circle out of it. The next geometric primitive is an ellipse. Now ellipse is a special type of, when you have one radius different to the second one, as in the 2 perpendicular axes, if they have 2 different radiuses, you get an ellipse. So circle is a particular type of an ellipse where the major radius and minor radiuses are equal. So let's just create this ellipse, close it, and let's move this ellipse out here. And now let's make this major radius 40 and this as 20. So you can see that this is your ellipse, and if I want, I can make this again same thing, arc of an ellipse, 90-degree arc of an ellipse. So if I make it 360, we get the angle, the full angle, or the full ellipse, 360 degree ellipses. Next, we have a point. So remember that circle we can create with 3 points. So if you would like to place 3 different points in 3-dimensional space, you can, and then you can create a circle out of those 3 points. Similarly, for a line, you need to give the X, Y, and Z dimensions for the start point and end point. So let's say we want to create a 100 millimeter long line in X direction. I click on this thing and I can create a line, but now I can't see that line. Why? Because it is hidden within this plane. So first, let's just change the location of that line, and when I click OK, you can see that there is a line from, originally it was from 0, 0, 0 to 100, 0, 0, but now we have changed the location of that line. Next on the list, we have a regular polygon. So it's the same principle. Say if I would like to create a pentagon, so I'll change this to 5, and the circumradius, let's make it 20. When I hit create, you can see that a pentagon is created here. Now let's move the pentagon away. Now again, with those properties or parameters, instead of 5, if I make it 8, you get an octagon. If you make it 6, you get a hexagon. And then the circumradius, if you change it to say 50 and recompute, you get a different size of a polygon. So these are all the different types of parameterized geometric primitives that you can create. So we created a plane. In fact, we created 3 different planes, and I showed you how to create them, giving different locations and parameters. Then we created an ellipsoid, we created a prism, a wedge, a helix, spiral, circle, ellipses, line, and a regular polygon, which is shown at the end.